Okay, we're now going to take a look at the third form of heat transfer, and we've looked thus far at conduction and convection. We are now going to move into radiation and look at radiation briefly. Radiation is quite a bit different from the other forms of heat transfer that we looked at, where those were involved with either macroscopic fluid transport or electron motion, lattice vibration, gas molecule movement within our liquids. So we looked at conduction, convection, and now we're going to look at radiation, which involves things in the electromagnetic spectrum, and that's why it's a lot different. And we'll notice the equations are a lot different as well. And so I'm just going to give a brief introduction to radiative heat transfer. So when we're looking at radiative heat transfer, we're talking about things in the electromagnetic spectrum. And typically, radiative heat transfer covers a portion of the electromagnetic spectrum. And we look at the infrared, visible, and then parts of the ultraviolet. Okay, so taking a look at the electromagnetic spectrum, we have the electromagnetic spectrum as a function of the wavelength in micrometers. And what we have, we go from the UV, which would be kind of on the purple side. That's not quite purple, but it's close. We go into the visible. Visible, what we can see with our eyes is between 400 and about 760 microns. And then we move into the near infrared and then eventually the infrared. And that is in this region. Now, thermal radiation, you could say, goes anywhere from about 0.1 microns up to about 100 microns. So this is where thermal radiation exists, or is radiation heat transfer. And so visible, obviously, that's what we can see with our eyes. Infrared, that is if we are looking in the infrared spectra. And so here I'm looking at you in the infrared, and you can see funny things. Watch my nostrils. So you can hear me breathing, and as I breathe in cooler air, and consequently you see the temperature change, and then we go back, and when I exhale it's hotter air, and so it's obviously a hotter temperature. So we can do neat things with infrared cameras as you're looking at right now, or we use things in the visible range. But what we'll be doing is we'll be looking at infrared radiation and radiative heat transfer. And for the most part, it is in this range right here. And solar radiation is typically would be anywhere from 0.3 up to 3 microns. So our eyes are only able to see a small portion of the actual spectra that exists. So if we're looking at solar radiation from the sun, that would be the range of solar radiation. For radiative heat transfer, however, the majority of the energy is going to be in the IR range, and that is where we have significant amounts of heat transfer. Everything is emitting and absorbing thermal radiation. So what we're going to do next is we're going to take a look at some of the equations.